Hi, this is Mrs. Basin, and today we're going to talk about representation of orbitals, which is section 6.6. So in the last section, we talked about the orbitals as being these three-dimensional regions where an electron is most likely to be found. And we talked about s orbitals, p orbitals, d orbitals, and f orbitals, which are all different three-dimensional shapes where you might find the electron. So the s orbital we talked about before. There is only one orientation of the s orbital. So if you imagine a three-dimensional space, there's only one way that that sphere could exist in the three-dimensional space. We also talked about the value of L for S is 0. Like we said, they're spherical in shape, and the radius of the sphere increases with the value of n. So if you look at the diagram there, this first one would be an S that would be found most likely at n equals 1. This would be an S at the second energy level. This would be an S at the third energy level. And you have to imagine these all kind of superimposed over each other. So this is where the electron would be found for n equals 1, n equals 2, and then n equals 3. And then they continue to get larger. The larger the value of n, the larger the three-dimensional space for this particular orbital. Okay, the next one we talked about was the p orbital. For the p orbital, there are three orientations. Sometimes these are notated with like a p sub x, a p sub y, p sub z. We are not going to necessarily do that, but if you see these little x, I'll call this p sub z. So we're not going to notate these this way, but if you do happen to see that, sometimes they give specific labels to the three different orientations. Each one of these orientations, like we talked about before, holds 2 electrons, and the value for L for a p orbital is 1. The other thing that it talks about here is a node. What a node is a place where there's a 0 chance of finding an electron. So for these, the places where you would look to find the electron would be in these kind of lobe shapes. You wouldn't find an electron in this node in the middle. Okay, the next one is a d orbital. The d orbital has 5 orientations, and you can see the 4 kind of makes sense, and then the 5th one's kind of weird looking. And they could also be notated the same way with subscripts that designate different versions of this or different orientations of this, but we're just going to look at it in terms of there are 5 different orientations. And then our last one are the f orbitals. So the last shape we need to look at is the f orbital. So the value of for an f orbital. So the last one we want to look at are the f orbitals. The value of L for an f orbital is 3, and there are 7 f orbitals. And again, these could all be notated by specific things to notate specific orientations. So then there are 7 orientations for the f orbital, and you notice these are a little more complex than the others.